Assalamualaikum and hi everyone. We are from Group 3. This is the topic for SCL MTS3710.
IRR, also known as unit, the rate of interest at which the present value of contributions from the investment is equal to the present value of returns into the investment. The value of I for which NPV I equal to 0. This is the formula that we use to find IRR, where N is equal to total number of periods, I equal to internal rate of return, city cash flow at time T. Basically, C is initial investment, is usually negative value, while C1, C2 is the future cash inflow, is positive value. For problem 1, find the IRR of a transaction that has the following net cash flow. On the question, we use the formula that we saw from the previous slide, where we started with the value of CK. With the question given, C0 is initial negative 1000, C1 is 450, and C3 is 650. Then we let 1 plus I equal to S, and then we multiply all of it into the S square, and then we get that S is equal to 21 over 22 and negative 3 over 5. The reason why we choose 21 over 22 because if we add the inflow together, 450 plus 830, we get a total return of 1080 ringgit, which is higher than our investment. This means the project makes a profit of 80 ringgit. Since the investment is profitable, the internal rate of return or IRR should be positive. The other is negative 3 over 5, which gives us I equal to negative 160%. Even though both are mathematically valid, we only accept the one that makes sense in the real world. A negative IRR like negative 160% means the project loses more than its value every year. But in our case, that does not fit because the project is actually gaining value. Therefore, we reject the negative IRR and accept the positive IRR of 5% because it reflects the real financial performance of the investment. Let's move on to problem 2 and the first one. It is the same like problem 1, that we get the values of x which are 1.3105 and negative 1.3105. Then we choose 1.3105 and minus midpoint and get the answer 0.3105 or 21.05%. This time, problem 3 is quite different to the previous problems. A project requires an initial investment of 10,000 at time 0. In year 1, we expect returns of 6,500 in total. That includes 5,500 plus additional 1,000. In year 2, we expect to receive 6,000. Again, we set up the IRR formula by equating NPV to 0. Solving this quadratic equation, we find the values of x which are 0.9725 and negative 0.5141. We choose 0.9725 and then we minus 1 with the 1 and get the answer negative 0.0275. A negative IRR is possible and acceptable in financial analysis. It simply tells us that the project returned less than what was invested. In this case, with an IRR of negative 2.05%, the project actually reduces value of the time and will not be considered a good investment. It helps decision makers about putting money into unprofitable projects.
Moving on, I will walk you through the concept of the time-weighted rate of return, or TWR for short. It's a really useful metric, especially when you want to measure the growth of an investment account or fund over a period of time. Basically, it compounds the returns over successive parts of the year, giving you a clear picture of the fund's performance itself. Let's start with the general formula for TWR. TWR on the left is what we are trying to calculate, the time-weighted rate of return. Inside the big square bracket, we have several terms being multiplied together, 1 plus J1, then 1 plus J2, and so on, all the way up to 1 plus JM. Each J term, like J1, J2 up to JM, represents the rate of return for a specific individual sub-period within your overall investment time frame. M is simply the total count of these sub-period. Finally, after multiplying all those individual growth factors, we subtract 1 at the very end. Now, how do we actually calculate each of those JK? We use this formula here. JK equals to FK over FK minus 1 plus minus CK. There's an alternative way to express the overall TWR formula, which often looks a bit more compact. It essentially combines the JK calculation directly into the main product. To help visualize these time points and cash flows, imagine a timeline like this. FK plus minus CK points mark the balances after any transaction at the specific time, which then becomes starting point for the next segment return calculations. Now, let's walk through a few problems to solidify understanding and see how these formulas work in practice. In this problem, a fund starts with 5,000 ringgit. Let's trace the changes. Fund decreases to 4,800 ringgit and a deposit of 800 ringgit was made. Proceeding to 1st of June, the balance was 5,200 ringgit and a withdrawal of 500 was made. On to the end of the year, the balance was 5,500 ringgit. Let's break this down into sub-periods and calculate each JK. When K equals to 0, JK is equal to 0 since there is no any cash flow. When K equals to 1, and using the formula JK equals to FK over Fk minus 1 plus Ck, we will get J1 equals to negative 0.04. When K equals to 2, J2 equals to negative 0.071. When it comes to K equals to 3, we will get J3 equals to 0.17. Now, let's calculate the TWRR using the compounded returns, and we will get 0.043 or 4.3%. The alternative method is also used for calculation, which also equals the same result. The next problem involves calculating the TWRR over several years with deposit and withdrawals. Let's calculate JK for each period. When K equals to 0, similarly we will get JK equals to 0 since the CK is equal to 0. When K equals to 1, using the formula we will get J1 equals to 0.3. When K equals to 2, J2 is equals to 0.042. And when K equals to 3, J3 is equals to negative 0.17. Next, we calculate the TWRR using the compounded returns. We will get 0.1243. Again, let's check with the alternative calculations show. We will get TWRR equals to 0.1285, 12.85%. Problem 3, and here's the scenario. So our goal is to find the balance in the fund on May 1st. Looking at the TWRR formula, we have two sub-periods from beginning of the year to May 1st. The balance goes from 2,000 ringgit to X. From May 1st to the end of the year, the balance after the withdrawal is X minus 100. And it grows to 2,250 ringgit by the end of the year. Now we can plug this into the TWRR formula and solve for X. Eventually, we will get X equals to 4,600 ringgit.
Okay, so for the first problem is to compute the IRR for the investment. The cash flow for the case study are as follows. On the January 1st, an initial investment of 50k was made. This is a negative outflow. On March 1st, an additional 5k was spent on marketing, also a negative outflow. On July 1st, an investor contributed 3k, which is a positive inflow. And lastly, on the 31st of December, the total revenue earned was 26k, a positive inflow. Okay, so in theory, we can calculate the IRR by solving the MPV equation, where MPV is set to 0. As stated in the slide, in this case, each cash flow is discounted based on its timing expressed in years. However, solving this equation manually can be a little complex, so to simplify the process, we use Excel SIR function, which is designed for cash flow with irregular time interval. The formula that we use is stated as follows. Hence, the SL return an IRR of 15.19% annually. Okay, now problem 2. To compute the TWRR, we refer to the table shown. The table summarizes the investment performance at different time period throughout 2024. The first column K represents the period index. The second column TK shows time in years from the start date. FTK is a portfolio balance or value at the end of each period. Between K equals to 0 and K equals to 2, since it is not started, we assume there is no change in the balance, so it remains at 15k and then 20k before the next deduction. And by the final period, K equals to 3, the balance increases from 23k to 26k due to the revenue in showing the return on investment. The fourth column CTK indicates the external cash flow injected during that period. At K equals to 0, there is no contribution. At K equals to 1, 5k for the marketing support. At K equals to 2, 3k from the investor. And lastly, there is no new cash flow in the final period, so G3 equals to 0. And the last column, JK, is the return for each subperiod calculated using the formulation in the slide. And inserting all this value into the TWRR formula, it will give us a value of 13.04%. Problem 3. The IRR of 50.90% reflects a strong return on investment driven by the effective use of fund and well-timed investment. Meanwhile, TWRR of 13.04% showing the business performance excluding the external investment. So this indicates that the steady growth throughout the year. So for the comparison, the higher IRR compared to the TWR suggests that the strong return was largely due to the timing of its investment rather than the business internal growth. So while the business performed well, most of the return came from the strategic investment. So in conclusion, the platform performance in 2024 was successful. The IRR highlights the excellent return from the investment timing, while the TWRR confirms the steady business growth. Okay, now shown here is the comparison of IRR versus TWR in general. IRR measures the overall profitability of an investment, taking into account both the amount and timing of cash flow. Meanwhile, TWR measures the performance of an investment manager by limiting the impact of external cash flow. In terms of use case, IRR is useful for evaluating entrepreneurial project and also business profitability. Meanwhile, TWR is ideal for evaluating fund performance and portfolio manager. In terms of sensitivity, IRR is highly sensitive to when cash flow happens, while TWR removes the timing bias by isolating the investment performance from the external cash flow. In terms of interpretation, higher IRR means more profitable project, while higher TWR means better investment manager performance. And its limitation is IRR can be misleading when dealing with non-conventional cash flow, while TWR may not reflect the actual money earned by the investor. The last part, group reflection. We face two main challenges, which are understanding the complex cash flow in IRR problem and also the conceptual difference between IRR and TWR. Inside, we learned that IRR helps to assess overall project profitability, while TWR focuses on investment performance, ignoring cash flow timing. Peer discussion helps us to clear up our doubt and deepen our understanding. So what we learned in this project is that we learned how to calculate and interpret both IRR and TWR accurately. We saw their real-world importance in financial decision. This project also taught us to present our findings clearly and professionally. And most importantly, we realized that the value of teamwork, responsibility, and also collaboration. Thank you.